Hi, I'm Ben Brown, and I'd like to thank both the SAPC and RCGP for giving me the 2023 GP Outstanding Early Career Researcher Award. I'd like to present to you some of the research I've been leading recently, which describes a new way of using artificial intelligence in online consultations. This work has been a collaborative effort between academics and commercial partners, and I'd like to thank all colleagues and participants who've been part of the project. I should also point out that as an employee of one of the commercial partners, Spectra Analytics, I'm a shareholder in the company. Online consultations are software that allow patients to contact their GP practice by submitting forms over the internet without needing to wait on the phone. Internationally, they've been promoted as a way to use resources more effectively, and they saw large-scale adoption since COVID-19, with virtually all GP practices in England now offering them. My team performed a systematic review of the literature of research on online consultations in primary care, and we looked at 63 different studies from 9 countries and 31 different systems. We found that although online consultations can have positive impacts such as increased patient access, they can also have negative impacts such as increased workload and perceived safety problems. And we found that actually some of these negative impacts are often related to how the online consultation system is designed. For example, forcing patients to describe their queries using multiple choice questionnaires rather than allowing them to write their own descriptions in free text increase both patient and staff workload. And we found that some of these negative impacts could potentially be mitigated by the use of technologies such as artificial intelligence to help triage. So when we talk about artificial intelligence, we're referring to the ability of computers to perform activities that we usually associate with human thinking, such as decision-making, problem-solving, learning. And when that comes to triage, it's about working things out like how urgent a patient request is, where's the best place for the patient to go, is it the GP practice, A&E, pharmacy, and who is the best person to deal with that patient to. So is it a doctor, nurse, administrative staff, or some other allied health professional? And there are broadly 2 approaches to artificial intelligence. The oldest way is called rules-based expert systems, where humans pre-program logical rules for the computer to follow, usually in the form of if-then. So in triage, this works particularly well for multiple choice questions. So for example, you ask the patient if they have chest pain, and if they say yes, you direct them to A&E. The newer way is called machine learning, and this involves giving the computer lots of real-world examples so it can work out patterns for itself. For example, you could give it lots of real online consultation forms submitted by patients and tell the computer for each one, is it emergency or not? So it can then work out for itself the patterns which may suggest an emergency. And there are pros and cons to both these approaches. So rules-based expert systems require a lot of time and effort to program and keep up to date, and they usually can't cover every real-life scenario because how can you program and account for everything? Machine learning, on the other hand, typically can deal better with real-world scenarios and also has the advantage of being able to learn and update over time. However, it requires a lot of high-quality data to do that. In our systematic review, we found only 4 papers that were published by evaluating systems that used AI triage. All the 4 systems were multiple choice question-based online consultation systems, and all used rules-based expert systems as their form of artificial intelligence, so they had drawbacks of both of those approaches. Only one of those studies actually evaluated the AI triage part of that system, and this system only focused on COVID-19, so ignored every other kind of condition that we see in primary care. So our aim was to develop an artificial intelligence that can triage online consultations, that doesn't rely on multiple choice questions and expert rules, where patients can describe their requests in their own words, and that can deal with all types of conditions that we see in primary care. The way that we did this was by building our own online consultation system called Patches, which stands for the Patient Automated Triage and Clinical Hub Scheduling System. And like all online consultation systems, patients access it online, but instead of answering lots of multiple choice questions, they can describe their request by answering a few open-ended questions that we would normally ask in a typical primary care consultation, like a description of the problem and any ideas, concerns and expectations the patient may have. The submitted request then enters an inbox at the GP practice where the patient answers can be reviewed, and they can then be contacted by the practice staff either in writing, back in patches, or by telephone. GP practice staff can also add triage decisions covering different aspects of the request, like how urgent it is. Is it an emergency that needs to be dealt with on the same day and possibly by emergency services? Is it an urgent request that should be dealt with within 48 hours, or is it something routine that can wait longer than 48 hours? And it's those triage decisions that we've used to build an AI triage model. So we've taken lots of real-world examples of requests submitted by patients to patches across the UK and fed them into a machine learning model, more specifically a type of deep learning model called a neural network. So it takes the text typed by patients in patches, and then also some characteristics of the patients themselves, like their age and sex, and the type of query that they've selected to predict whether a request is routine, urgent, or emergency. And the AI triage system communicates its predictions in two ways. So firstly, it will send patients messages to suggest they contact emergency or out of hours services if they have an emergency or urgent request out of hours. And indeed, it will also provide the patient with self-help advice if it's for something more routine. For GP practice staff, it will highlight emergency and urgent requests with red and orange flags respectively in the inbox and send them to the top so they can be reviewed and dealt with sooner. GP practice staff can still go in and change and overrule the triage decision if they disagree with the AI, or indeed if they agree with the AI's decision, they can keep it if they think it's correct. We've evaluated the AI triage system in what we call early adopter GP practices. We've done that using both qualitative and quantitative methods. So we've undertaken interviews with 20 staff, including GPs, practice managers, and receptionists. And those have happened in 14 GP practices in London and Northwest England. We've also undertaken a quantitative evaluation of the predictive accuracy of the AI triage system. And how we've done that is we've used the triage decisions from staff as the gold standard. So when the staff have not changed the prediction made by the AI, we have considered the AI as being correct. And where the staff have changed or overruled the prediction made by the triage system, then we've considered it incorrect. So in terms of the qualitative results, we found three key themes within the interviews. The first was that participants would much rather prefer the AI triage system to be safe rather than it have any other benefits in terms of efficiency or workload reduction. So as you can see from this quote from a GP, they would much rather prefer to err on the side of caution and pick up urgent and emergency requests rather than it have any other benefits. So translating that into a performance metric, they would much prefer the system to have high sensitivity rather than it have, for example, a high specificity. So sensitivity is much more important. The second theme was around how the AI triage system impacted workload. So in this particular quote, you can see that the receptionist is saying that without the AI beforehand, they would often get lots of requests, fill up their inbox, and they'd often have to scroll down, read each one until they came across a particularly urgent request. Now, without the AI, that could potentially cause some clinical safety issues if the patient waited a long time, and that was inappropriate. But with the AI, they found that because the requests were flagged when they're urgent or emergency, it drew their attention to them, and they would be able to pick them out and deal with them sooner. And then finally, there was a theme around how the AI impacted different roles within the GP practice. So this particular quote is from a GP and saying that they can definitely see the benefit of the AI for non-clinical staff, so those such as receptionists, who are often the ones that are typically dealing with the online consultation requests as soon as they come into the practice, and then they're passing them on to GPs or other clinicians. if they feel it's necessary. And what they're saying is that often those members of staff don't have clinical training by definition, but the AI is helping them and support them to make those decisions. And if it's doing that in a safe way, that can be quite valuable. In terms of the accuracy of the AI triage system, we tested its performance on nearly 20,000 different requests submitted by nearly 10,000 different patients. On the left-hand side of the screen, you can see a summary of the type of patients and requests that were submitted. And on the right-hand side of the screen, you can see the performance metrics. So at the top, there's a confusion matrix, which compares the predictions from the AI system versus the actual decisions made by GP practice staff. And then underneath, you've got the resultant metrics that come from those. So looking at sensitivity, specificity, positive predictive value, and negative predictive value. And what I'll do is I'll just focus on the metrics table. So in particular, the sensitivity or the true positive rate, because as you remember, one of the key themes from the interviews with GP practice staff was that they would prefer the sensitivity of the AI system to be high as possible, really, and they didn't want it to miss any or miss as few urgent and emergency requests as possible. And as you can see, the sensitivity of the AI system was high at 93.7%. So that means for every 100 truly urgent or emergency requests submitted by patients, the AI will correctly pick up 94 of those. Now, the key question around there is, although it sounds high, how does that compare to usual practice? And in this context, usual practice could be seen as how well a doctor would do when assessing online requests. Now, there isn't any literature out there that looks specifically at online consultation systems and how well doctors perform when triaging them, but there is some literature that looks at the accuracy of diagnosis at different levels of acuity. And particularly there's this paper published in 2016 where doctors were assessed written vignettes, and their accuracy of diagnosis was evaluated, and that suggested that doctors have a sensitivity of around 80%, so 79% when diagnosing these requests, these written vignettes. So if we kind of use that as a proxy for triage, then we can see that the AI performs significantly better than the literature suggests doctors do. So in summary, online consultations could benefit from artificial intelligence to both reduce workload and increase safety in primary care. As far as we're aware, Patches is the first online consultation system that uses artificial intelligence to triage patient queries written as free text rather than multiple choice questions. Safety, in terms of a high sensitivity, is most important to GP practice users when evaluating an AI triage system. Patches may support safe practice workflows and non-clinical staff in particular. In terms of future work, we are conducting further evaluations to assess the impact on Patches in terms of reducing care delays and also evaluating its accuracy versus GPs. Thank you for watching, and thank you again to the RCGP and SAPC for this outstanding early career researcher award.